Lesson 5.4 is on solving compound inequalities. And we've talked a little bit about using the words and or when we're talking about inequalities. So what we're going to do now is we're going to actually put them in the inequalities and see what that does to their solution set, depending on if it's and or if it's or. We're still working within the same Common Core standards, okay, ACED1 and AREI3. You know vocabulary that we've already talked about: compound inequality, intersection, and union. So let's take a look. Okay, our first example. Solve and graph this compound inequality. And again, it's a compound inequality because we kind of have two inequalities put together. It's kind of like a compound sentence in language arts. Okay, so we want to solve this compound inequality, and then we want to graph the solution set. So when we do this, we want to split it up. Okay, we're going to use the word and. This is an and statement. And this is how we're going to write it. We're going to take the first half, and we're going to write it like this. Z plus 2 is greater than 7. And then we're going to use the back half. Z plus 2 is less than or equal to 11. So really what we're doing is we're splitting it apart, and we're doing two separate inequalities here. So once you solve this one and once you solve this one, okay, we're going to take a look at their solutions. So to solve this one, you're going to subtract 2 to both sides, and on this side you're going to subtract 2. Okay. And when you get that, you get z is greater than 5 and z is less than or equal to 9. Okay, again, we just split those two apart. We took the middle and we put it with the front, and we took the middle and we put it with the back. So here's our two inequalities. So what we want to do is we want to graph those two. So let's graph this first one. Z is greater than 5. So if we graph z is greater than 5, here's what our graph looks like, right? Here are your numbers greater than 0. If we graph z is less than or equal to 9, here's this. Okay? So what we want to do is we want to look at the intersection of them. What do they have in common here? Okay? Well, we're saying that z has to be greater than 5 and it has to be less than 9. So here's the only part that they have in common, these two pieces. I'm not going to make you do these two. Oops, sorry about that. I'm not going to make you do these two. If you can see by looking at these two sets, when you recombine them, like right here, when you recombine your two answers from here and from here, you can see that z has to be greater than 5 and it has to be less than or equal to 9. So here's your solution set right in here. Okay, z is greater than 5, but it also has to be less than 9. So here's the only part of your solution set right here when you graph it. Okay, so this would be your graphing part, and then if you wanted to rewrite it as a compound inequality, you would write it like this. Okay, let's take a look at your example problem. Okay, here we have your compound inequality. Okay, so the first thing you're going to want to do is you're going to want to split them apart. Okay, so again, we took x minus 2 is greater than negative 3 over here. We took x minus 2 is less than 5, and we put it over here. Go ahead and pause the video for a second and solve those two inequalities quickly. Okay, well, for both of them, you're going to have to add 2 to both sides. Okay, that's kind of one of the nice things about this. You're pretty much doing the same thing each problem. It's just your end result will be a little bit different. So when you add 2 to both sides, this is what you're going to get. X is greater than negative 1 and x is less than 7. So if you can think of that visually, greater than negative 1 but less than 7. So here's what your graph is going to look like. Okay? We have open circles because they don't equal 7 or negative 1. Okay? But it has to be greater than, here's your greater than negative 1, but it also has to be less than 7. So here's your solution set on your number line, okay? And if you're going to rewrite that as a compound inequality, this is how you would write it. X is greater than -1 and it's less than 7. And here would be your solution set. Okay? Okay, let's take a look at a word problem here. A ski resort has several types of hotel rooms and several types of cabins. The hotel rooms cost at most $89 per night, and the cabins cost at least $100 per night. Write and graph a compound inequality that describes the amount that a guest would pay per night at the resort. All right, so let's translate this. Cost per night is at most $89, or that's if you're renting a cabin, or if you rent, that's a room, I'm sorry. The cabin, if you rent a cabin, the cost is at least $109. So let's change those words. Okay, let's change those into math problems here. The cost per night will represent N. At most is a less than or equal to 89, and at least is a greater than or equal to 109. So here are your two inequalities, and it is a compound inequality. It's an or statement. It's one or the other. Okay. So when you graph that, here's this part. N is less than or equal to 89. If you graph the other set, you're at 109 or greater. So to find the union, okay, here's what your graph is going to look like. It's kind of like you're putting the two graphs on the same line. So this is what it will look like. Here's your solution set written out as a compound inequality, and again you're using the or because it's one or the other. And here's what your graph would look like. Okay? All right, so now it's your turn here. A professional hockey arena has seats available in the lower bowl level that cost at most $65 per seat. The arena has seats available at the club level and above that cost at least $80 per seat. So there's kind of your keywords. Okay? At most 65 and at least 80. Okay, so use that to kind of help you. It says write and graph a compound inequality that describes the amount a spectator would pay for a seat at the hockey game. Use the previous example to help you set this up. So they want you to write the compound inequality and then graph it. So go ahead and pause the video and try this problem. All right, let's start by writing our compound inequality. Okay, if we let X represent the cost, if you buy a lower bowl, it's going to be less than or equal to 65. Okay. If you buy a club level or above, it's going to be at least $80. So X is going to be greater than or equal to $80. Here's your compound inequality. Okay. You can buy one or the other, or you can buy both. Okay, and we talked about that, what or means in math. So now let's graph it. Okay. Here's 65. Here's less than or equal to 65, or here's greater than or equal to 80. And that's what your graph is going to look like. Okay? You're not going to be buying anything in this space right here. There aren't any tickets available for $70 or $75 or $73. Okay? There's no ticket prices in this range right here. So that's why there's that open space. It's either 65 or lower, or 80 or higher. Okay? All right, let's look at the last example here, example 3. Solve and graph a union. Okay. We want to graph this compound inequality. Okay? So again, you've got almost two separate problems going on here. Okay? So you're going to solve this side and solve this side. Again, that's what the first 3 lessons were on. So if you graph, or if you solve both of those, this is what you end up with. K is less than or equal to 8, and K is less than or equal to -2. So when you graph that, before you even graph it, you might be thinking, this might be a little weird. So if I graph K is less than or equal to 8, this is what my graph's going to look like, right? if I graph k is less than or equal to negative 2, here's what it looks like. You can see that this piece right here is already kind of included in the one above it. Okay, this piece right here is kind of already included in that part. So when you go to graph your line, that's what this is going to look like. You're just going to use this one right here. Okay, your answer says, notice that the graph of k is less than or equal to 8 contains every point in the graph of k is less than or equal to negative 2. So the union of the graph is k is less than 8. So that's actually going to be your solution set right here. Look, it's written in set builder notation, but k is less than 8 because this is already included in that. Okay, you don't need to write it again. It's already part of it. Okay, so that might happen sometimes. You might have something that actually overlaps, and that's okay. All right, so use this to try your last example, okay, and then we'll check it. So go ahead and pause the video. All right, so let's set both inequalities up. Let's see how you did. I'll just show you my work. I got x is greater than negative 5 and x is greater than 1. Okay. So if you think about it, x is greater than negative 5 and x is greater than 1. You can kind of see how they overlap. Here is x is greater than negative 5, and here x is greater than 1. And you can see where they overlap. This solution set right here is going to encompass this one. This is already included in that. So really your solution set is just right here. X is greater than negative 5. Again, it's an overlap. Okay, so that would be your solution. We're going to spend some time on this, and we'll make sure that everybody understands what's going on. We'll spend probably about 2 days on this, okay? So come tomorrow. If you have any questions, write them down, and we will discuss them first thing.